Strategy number 3, coming right up. This often happens, especially when we use trigonometry. Strategy number 3 is going to be use the calculator, specifically your table, I would say. Don't forget that you're starting in the table at whatever x is approaching, and your change in the table is going to be 0.001. Special note, whenever using trig, I would probably 99% of the time be in radians. Okay, so if I plug in, I get 1 minus the cosine of 0 all over 0. It's 1 minus 1 over 0, or in other words, 0 over 0. Nonsense. Doesn't work. Have to use a strategy. There's not really any algebraic stuff I can do. That's one reason I'm going to use my calculator, besides the 0 divided by 0 thing. The second reason is you are getting close to 0. Although I know stuff on the unit circle like pi over 6, pi over 3, pi over 4, all that kind of good stuff, what about 0.001? What's the cosine of that? What about 0.0001? What's the cosine of that? I have no idea. So that's why I'm going to use my calculator. So I'm going to grab my calculator. I'm going to type this stuff in. I'm going to use the strategy that I talked about. In my calculator, I'm going to make sure that my mode's in radians, because I always start in radians just in case. And I have a fraction, so I need to use parentheses. 1 minus cosine divided by x. And in my table, I'm going to start at the number I'm approaching, which is 0, and I'm going to go up by 0.001. Auto, and I look at my table. And here's what I see in my table. Did I forget something? Oh, see? Bad, 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 bad. So I need to
I was going to say thousands.
Put in a parentheses, thank you. Good catch. And now I'll look at my table, and this is what I see. I see this negative 1e negative 3 for my y value. What does that mean? Joe? 3 words.
Decimal place behind 0.
That's 4 words. Small, negative, number. That's what it means.
Oh.
Yeah. It means move the decimal left that many spots. To the right I see 1e negative 3. That means small, positive number. At 0 I get an error, but what number should that be? 0. Because I have small negative numbers to the left, small positive numbers to the right. Stand up, sit down, fight, fight, fight. Is anybody awake in here? Okay, I'm just going to keep talking then. Just making sure. Just want to check, see if anybody was awake. So I'm going to draw this table just so you can kind of see what's going on. It's really quiet in here. What the?
You do that every class.
It's annoying.
It's really funny to watch him video.
Oh, he is here. Who? Tristan. Because I heard him, but I couldn't see him.
Well, Joe Green's last was
That's probably why it's quiet.
He's been quiet lately.
No,
Quiet lately.
It's caffeine crash.
no rephrasing of questions today.
So this is the table of what's going on. Now these E things are not answers ever, but they kind of tell you what's going on. And so as I look at what's happening, I see this thing right here, that my Y value, which is my limit, actually has the word error. But that doesn't matter, because the number that I'm getting really, really close to is 0. Okay, in our last problems, we're going to talk about something called one-sided limits. That means as you're approaching from the left or from the right. And I'll show you what that means in the context of each of our problems. So let's say that we're looking at letter A. And now we're going to graph letter A. This is what it would look like. I want you to watch very carefully to what I'm asking and see if you can answer this question. First question. What is the limit as x approaches 2 of my function? What, Drew? Does not exist. Very good.
Oh,
Because from the left, I am approaching -1. From the right, I am approaching +1. So at 2, the limit does not exist. I'm approaching 2 different numbers. We covered that yesterday, actually.
I remember that.
Good listening skills. Now I'm going to ask a different question.
Oh,
What is the limit as x is approaching 2 to the left of 2 of the function? Or in other words, the limit as x approaches 2 from the negative side of that function.
does not exist.
Joe,
Does not
wrong.
Oh.
Tristan, correct. -1. If I go back and I look at my graph, what this is asking me is as I approach the x value that I'm talking about, which in this case was the number 2 on the x-axis, what is the y value coming from the left? -1. Next question. What is the limit as x approaches 2 from the right-hand side, or the positive direction of that function? Adira? Positive 1 is correct. Because as I come in from the right-hand side, all of the y values are +1. And the reason that the limit doesn't exist is because if you look at what's happening from the left, and you look at what's happening from the right, the two limits are different. And when a limit exists, and you can actually give me the limit, it's because these two numbers on the right-hand side, and the orange and the purple, are the same y value. That's why there is a limit. And that's why originally, in the light blue, we always talked about this being does not exist. So on the test, if they just say, give me the limit as x approaches 2 for this problem, you're going to say does not exist. If they ask you what happens from the left, you're going to say -1. What happens from the right, you're going to say +1. Our last problem that we're going to do today is a piecewise function. We're going to skip number 6 because our next lesson covers all that kind of stuff. So in the piecewise function, these two things that are on the end here are called so I have two separate functions being graphed. One of them is the light blue, and one of them is the pink. Let me draw a graph here. The important x value that I need to think about looks like is +2. if I make a table to graph these things, let's look at the light blue function. In the light blue function, if I make an xy table, or x f of x table, it says the condition is 2 and greater than 2, right? So I start at 2, and then I want numbers that are bigger than 2, like 3 and 4, for example. Those are x values that are bigger than 2. So I plug in a 2 and I get 4. I plug in a 3 and I get 5. I plug in a 4 and I get 6. Or in other words, I'm going up to the right. This is a line. So when I graph this thing, and this is kind of a bummer because I didn't do it, I have a solid dot because there was an equal sign and I'm going up and to the right. It's a line. If I look at the pink graph, which is an x squared graph, it's saying that I want everything less than 2. But in piecewise functions, we always start at the condition. So I'm going to start with the x value of 2, but I want the numbers that are less than that, like 1 and 0, so on and so forth. So if I plug in a 2 into the pink function, I get 4. If I plug in a 1, I get 1. If I plug in a 0, I get 0. What kind of graph is that pink function?
Parabola.
It's a parabola. Except at 2, 4, I don't have a solid dot. I have a circle. And I just happen to know that this is a parabola, so I know it would look like this.
Oh.
So you have a parabola in the pink with an open circle at 2, 4, a line starting at 2, 4 and going up to the right in the light blue. And the question is, what is the limit as x is approaching 2 of my function?
Just
Coming in from the left, coming in from the right. If you look at both tables, at 2, I get 4 in the blue, and at 2, I get 4. Remember, limits are y values. What are both of the y values? 4. So I know for a fact the limit is 4. In fact, it wouldn't have mattered if they would have asked me what's the limit from the left. Because as I trace the pink graph coming in from the left, the y value that I'm getting closer and closer and closer to, as I get close to 2 on the x-axis, is 4 on the y-axis. If I came in from the right on the blue axis, and I said what's the limit as x is approaching 2 from the right-hand side, or the positive direction, so I'm coming in from here and tracing that blue line coming down, the y value I'm getting closer and closer and closer to is 4. It doesn't even matter if it existed or not, it's the one you're getting closer and closer to. So limits are y values, and it's whatever you're approaching from both sides. And that's why, in the previous example, with the absolute value thing, the original question in light blue we had to say does not exist. We were not approaching the same y value.